Okay students, a colorful morning to one and all. From last 5 days, we are discussing about the kinematics. What is the use of kinematics? Anyone? So what is the use of kinematics? So, main use of kinematics. Nowadays, everyone thinks to go one place to another place in less time. In order to have our journey in less time, we are going to prefer aeroplanes. So, for aeroplanes to land or to take off, it needs some airport. So, in less area, we want to build the airport. So, how? If you are well in kinematics, we can build airport in less area. Not airport, mainly runway. Okay? How? That we are going to see in today's problem. See? A plane lands at a speed of 68 meter per second and slows down at the rate of 4 meter per second square, and how much runway is needed to stop the plane. This is the problem. Now we want to construct a small runway which is necessary, not large runway and waste. We should not waste the land. So now we are going to solve this problem by using kinematic equations. So what we want to calculate, how much runway is needed. That means simply we want to calculate the distance. This is the factor we want to calculate. What are the given factors? Here a plane lands at a speed, no doubt initial velocity is given, initial velocity. What is the initial velocity? 68 meter per second. We know that initial velocity is represented by the letter U. 68 meter per second. And slows down at the rate of, first we want to observe the units. Here the unit is meter per second square. Meter per second square, it is the unit of acceleration. So acceleration is given. Acceleration, that is 4 meter per second square. Now another indirectly one value is given. How much runway is needed to stop the plane? Here there is another factor, that is final velocity is also given. To stop means final velocity is 0. Final velocity is 0. V equal to 0. Now we know we want to calculate distance, initial velocity we know, acceleration is also given, and final velocity is also given. We are going to see all these terms in only one kinematic equation, that is, what is that kinematic equation? Third kinematic equation, V square equal to U square plus 2AS. V square equal to U square plus 2AS. Here, one more thing we want to note. Here, a plane lands at a speed of 68 meter per second and comes to rest. Here, the velocity is slowly decreasing. When the final velocity is less than initial velocity, when final velocity is less than initial velocity, then what type of acceleration it will have? Negative acceleration. It is also known as retardation. So, minus 4. Why we have written minus 1? Here the final velocity is less than initial velocity. So, retardation. So, minus 4. Now we are going to substitute. V, what is the value of V? 0. 0 square, that equal to U. What is the value? 68 whole square plus 2 into A, that is minus 4 into S. So we are going to bring 68, that becomes minus 68 whole square, that equal to plus into minus, minus 4 into 2, 8, minus 8 into S. Minus minus, jump line. So 68 square, we want the value of S. S equal to 68 into 68 by 8. Or we can, for a calculation, let it be 4 into 2. For simple calculation. So cancellation, 4 ones, 4, 4 twos, 4 ones, 4, 2, 28, 4 sevens, 28. In the same way, 2 ones, 2 threes, 6, 2 fours, 8. 34 into 17. What is the value of 34 into 17? It is nearly 578. So how much runway we needed? 578 meters is the runway needed to stop the aeroplane. Okay? This is the method to do. Once again, have a look at the problem. Right, coming to the next numerical. This is the next problem. A car starts from rest and has a uniform acceleration of 2 meters per second square. Find the speed of the car after 5 seconds. This is the problem. Now, in physics, in order to do the problem, first we want to write down the values in the given problem. And what is the term we want to calculate, that we want to see. First, if you understand the problem, a car starts from rest. This is very important. Starts from rest means initial velocity is given. So initial velocity, initial velocity, that means u. Rest, it starts from rest, so initial velocity is 0. When it starts from rest, initial velocity is 0 and has a uniform acceleration. That means simply acceleration is given. Acceleration A is given. What is the acceleration? That is 2 meters per second square. Now, time is also given. We want to find the speed of the car after 5 seconds. So time is given. Time t equal to 5 seconds. Now we want to calculate velocity. Which velocity? Final velocity. So final velocity v equal to question mark. So we are having initial velocity, final velocity, time and acceleration. So which kinematic equation is useful means first kinematic equation. We want to understand carefully. So v equal to u plus at. This is the first kinematic equation. V equal to u. No doubt it is 0 plus a. Acceleration it is 2. Time it is 5. Therefore v equal to 0 plus 2 into 5. It is 10. So the velocity at the end of 5 seconds will be 10 meters per second. Have an idea. So look at this problem carefully for 2 seconds and try to understand the problem. Okay, careful. Right? Coming to the another numerical. A bus is traveling at 72 kilometers per hour. Brakes are applied and the bus comes to stop after 10 meters. Find the deceleration of the brakes. Now, students, pause the video and try to do the problem. Okay? If you are unable to follow, look at the board. Right. Here, what we want to calculate? Acceleration. Acceleration we want to calculate. Acceleration, what type of acceleration it will have? Negative acceleration. Why means? Here, when brakes are applied, it comes to rest. When it comes to rest, the final velocity will be 0. That means the final velocity is less than initial velocity. So it will have negative acceleration. So what are the given values? Initial velocity is given. Initial velocity. That is u is given as 72 kilometer per hour. if you, this is initial velocity. Next, distance is given 10 meters. Distance equal to S equal to 10 meter. At the same time, if you observe, it comes to rest when brakes are applied. That means final velocity is also given. Final velocity V equal to 0 meter per second. Next, we want to calculate deceleration. Simply negative acceleration. Deceleration. We want to calculate. Now, which formula is well suitable? So, we are having initial velocity, distance, final velocity, acceleration. Which? Third kinematic equation. Very good. But before doing this, observe one very important thing. All the values should be in same unit. That is in same system. Here, the distance is measured in kilometers. And here the distance is measured in meter. Here the time is in hours. So, we should convert this kilometer per hour into meter per second. We know how to convert kilometer per hour into meter per second. That is 72 into, we want to multiply with, right, 5 by 18, right, 5 by 18 meter per second. So 18 ones, 18 fours, right, 18 fours. What is the value of 18 fours? Then, right, 18 fours. 4 into 5, that is 20 meter per second. The initial velocity is 20 meter per second, final velocity is 0, distance is 10 meters, deceleration. So, simple formula, V square minus U square equal to 2AS, or V square equal to U square plus 2AS, no doubt. So, V square, what is the value of V? 0. 0 square minus U, what is the value of U? 20. 20 square equal to 2 into A, we want to calculate, yes, 10. Therefore, 20 square, it can be written as 20 into 20 by, we want the value of A. So, 2 into 10, when it becomes this side, it becomes divide. 2 into 10. So, 10 ones, 10 twos. 2 gets cancelled. A equal to minus 20 meter per second square. Here minus indicates it is having negative acceleration. So, this acceleration is known as retardation or deceleration. So, this is the answer. So, if you write minus, it should be called as acceleration. If you neglect the minus, we should call as deceleration. Okay, look at the problem. Okay, students, coming to the last numerical of today's class. So, this is an object is allowed to fall freely from a tower of height 39.2 meters. At the same time, another stone is thrown from the bottom of the tower in vertically upward direction with a velocity of 19.6 meter per second. Calculate when the two stones meet. So, before going to do this problem, we are going to see how in pictorial representation. Let us consider this is the tower. Here the height of the tower is given as 39.2 meters. So, the entire of the tower height is 39.2 meters. Now, if you understand the problem, a stone is dropped from the top of the tower. Let us consider the dropped stone is number 1. It is released like this. At the same time, from the foot of the tower, that is from the ground surface, another stone is projected vertically upwards. That means this stone moves in upward direction, whereas the first stone moves in downward direction. So one is going to move like this and another one is going to move like this. So after some time they are going to meet at one point. At what time these two stones are going to meet? Now we want to calculate the time. After what time the two stones are going to meet. So in order to do like these problems, first we want to calculate the distance travelled by the first stone. In the same way, we want to calculate the distance travelled by the second stone. And that total distance will be equal to the height of the tower. If we equate that, from that we can calculate the time. So first we are going to calculate the distance travelled by the first stone. So distance travelled by the first stone. We don't know the time. So let us consider they will two meet at a time t. So in t seconds the two stones are going to meet. So indirectly we are going to take time equal to t seconds. Now we want to calculate the distance travelled by the first stone. So when we observe the kinematic equations, we are having more kinematic equation, that is 4 kinematic equations. In that 4 kinematic equation, in order to calculate the distance travelled by the body, this formula is very suitable. S equal to ut plus half at square. That formula will be very useful. So S equal to ut plus half at square. Here, yes, we want to calculate the distance. Let it is S1 equal to u. It is falling freely. When it is falling freely, the velocity should be taken as 0. So 0. We should not take as 19.6. It is the velocity of the second body, not the first body. So 0 into t plus half into, as it is freely falling, we can take a equal to g. In the last class only we have discussed, we can take a equal to g, that is 10 meter per second square. For just we are going to take g. T, the time is t, so t square. So S1 equal to half into g into t square. Let us consider this is equation 1. In the same way, we are going to calculate the distance travelled by the second stone. So same formula. So distance travelled by the second stone, S equal to ut plus half at square. Here, yes, let us consider it is S2. U we should not take as 0. Why means here it is projected with a velocity of 19.6. So 19.6 into t plus here half into a. We want to take minus g. Y means the body is moving upwards. So minus g into t square. Therefore, S2 equal to 19.6 t minus plus into minus half gt square. So this is the distance travelled by the first body and this is the distance travelled by the second body. The sum of the two distance will be equal to the height of the tower. So S1 plus S2, that will be equal to the height of the tower h. S1, what is the value of S1? Half gt square. So what is the value of S2? That is plus 19.6 t minus half gt square equal to h. What is the value of h? That is 39.2. Right, plus half gt square minus half gt square gets cancelled. Therefore, 19.6t equal to 39.2. We want the value of t, that is time. So t equal to 39.2 divided by 19.6. So how to calculate? 19.6 ones, 19.6 twos. So t equal to then to 19.6 into 2, that is, what is the value of 19.6 into 2? To 6, 12, to 9, 18, plus 19, to 1s, 3, 39.2. So t equal to 2 seconds. After 2 seconds, the two stones are going to meet. So in this way, we want to do the problem. Until then, have a fantastic Friday. Bye.